Designing Financial Analytics Dashboards. In this lesson, we will learn how to build interactive finance dashboards using real stock market data. Dashboards help analysts and investors make quick, informed decisions by visualizing key market metrics and trends. You will use Python to fetch, transform, and visualize live data, essential skills in real-world financial analytics. By the end, you will be able to assemble and display valuable analytics for finance using live Python code. Running the cell now. We import the warnings module to suppress unnecessary warnings. We use filter warnings to ignore warnings for cleaner output. We import pandas for flexible finance data manipulation and analysis. We import NumPy for calculations, especially for handling stock returns and random numbers. We import Ifinance to download real stock data directly from Yahoo Finance. We import Matplotlib for plotting and creating visual financial dashboards. We import Seaborn for improved, attractive charts in our analyses. Running the cell now. This code snippet sets up the environment by importing essential libraries for data fetching, manipulation, and visualization, while suppressing unnecessary warnings. Notice there's no output here because this step is all about preparing the tools needed to build your interactive financial dashboard efficiently. This foundation ensures smooth processing of live stock market data in the subsequent steps. Now try running the import block and check for error messages. Data concepts for financial dashboards. We will use real daily OHLCV, open, high, low, close, volume, data for multiple major stocks. The data is in long format, each row corresponds to one date and one ticker. Key columns include date, ticker, open, high, low, close, volume. Dashboards display metrics like price trends, daily changes, sector breakdowns, and risk statistics. Common beginner mistakes. Using incorrectly reshaped data. Plotting with mismatched indexes. Failing to check for missing data. Running the cell now. Let us download and preview 1 year of daily OHLCV stock data for our dashboard. We list 5 major tech stock tickers to include in the analysis. We download 1 year of open, high, low, close, and volume data for all tickers from Yahoo Finance. We reshape the multi-indexed columns into a tidy long format, 1 row per date and ticker. We remove leftover index names for a clean data frame display. We print the dataset dimensions to check the amount of data loaded. We display the first 3 rows as a quick preview. Running the cell now. This output confirms that the data is correctly transformed into long format, with 1 row per date and ticker, totaling 1,255 rows and 7 columns including the key OHLCV fields. Notice how the head of the dataset shows daily prices and volumes for different stocks on the same date, demonstrating readiness for dashboard metrics like price trends by ticker or date. This structure ensures flexibility and consistency when building visualizations across multiple securities. Can you spot which tickers are included? Try using OHLCV, ticker.unique. Beginner example 1, filter by ticker. To analyze one company in detail, filter the long data using its ticker symbol. This lets us quickly extract all rows for a selected stock. Running the cell now. We select all rows where the ticker is Apple, Apple Incorporated. We display the first 5 days of Apple trading data. Running the cell now. The output shows a filtered data frame containing only rows where the ticker is Apple, focusing on Apple stock data. Notice how all rows have the same ticker, and key columns like date, close, high, low, open, and volume give a snapshot of Apple's daily trading activity. This filtering step is crucial for isolating data by company to facilitate detailed analysis. Try selecting the Microsoft or another ticker. Beginner example 2, create a basic price plot. Line charts show changes in stock price over time. This is the most common way to visualize stock movement in a dashboard. Running the cell now. We set the figure size for a larger plot. We plot date against close price for Apple. We add a descriptive chart title to clarify what is shown. We label the x-axis with date for clarity. We label the y-axis with close price, USD. We show a legend so users see what the line represents. We improve spacing with tight underscore layout. We display the plot. It will appear below this cell. Running the cell now. This line chart displays Apple's closing stock price over the past year, showing how the price changes day to day. Notice the key columns used: date on the x-axis to represent time, and close price on the y-axis to track stock value. This basic plot helps beginners understand how to visualize stock trends clearly in a dashboard. Try plotting high or low instead of close. Beginner example 3, calculate daily returns. Dashboards often show daily returns, the percent change in closing price from one day to the next. This helps investors and analysts quickly spot volatility. Running the cell now. We calculate the daily return for Apple as the percent change in closing price, multiplied by 100. We print the date, close price, and daily return for the first week. Running the cell now. This output shows the daily returns calculated as the percent change in closing prices from one day to the next, with the first value as NaN since there is no prior day to compare. Notice the small fluctuations in the daily underscore return column, reflecting typical market volatility. This helps highlight how such returns can be quickly computed and analyzed for trends in a stock dashboard. Which date had the highest single-day gain or loss? Intermediate example 1, pivot to wide for multi-ticker displays. Dashboards often need to show price lines for multiple stocks simultaneously. Pivoting reshapes the data so each ticker is a column. Running the cell now. We use pivot to transform the close price data so that each stock ticker appears as its own column. We print the first 5 rows to check the format. Running the cell now. This output shows the pivoted data frame where each stock ticker is now a separate column with closing prices indexed by date. Notice how the shape has changed from long to wide format, making it easier to compare price trends across multiple stocks side by side. This reshaping is key for building dashboards that display multi-ticker price lines clearly and efficiently. Try plotting all 5 lines on one chart using close underscore wide. We prepare a new figure with a wider aspect ratio. We plot all the tickers' closing prices on the same axis using the wide data frame. We add a title explaining the chart's theme. We label the vertical axis with price in dollars. We label the horizontal axis with date. We add the legend in the upper left for visibility. We improve the spacing. We display the plot. Running the cell now. This line plot displays the closing prices of multiple tech stocks over the past year, with each ticker represented as its own column after pivoting the data wide. Notice how the trends for each stock are clearly separated, making it easy to compare their performance simultaneously. This visualization shows the benefit of reshaping data into a wide format for multi-ticker dashboards. Which ticker seems the most volatile visually? Intermediate example 2. Heat map of daily returns. Correlation heat maps helps in visualizing how stocks move together. It is useful for quickly spotting diversification or concentration risk. Running the cell now. We compute daily returns as percent changes for each ticker. We calculate correlation between returns for all ticker pairs. We set up the figure for the heat map. We plot the heat map with colored cells and numeric annotations for clarity. We add a title to explain what is plotted. We show the heat map. The more red or blue, the stronger the relationship. Running the cell now. The heat map displays the correlation matrix of daily returns for different stocks, with values ranging from -1 to 1 indicating how similarly or oppositely the stocks move. Notice clusters of high positive correlation in warm colors, which highlight groups of stocks that tend to move together, and cooler colors where correlations are weaker or negative. This visual helps identify potential diversification opportunities by spotting stocks that do not move in sync, directly aligning with the lesson's goal of assessing portfolio risk through correlation. Can you find any pair that moves almost identically? Intermediate example 3, rolling volatility chart. Volatility, moving standard deviation of returns, is a key measure in dashboards. Rolling volatility shows how risk changes over time. Running the cell now. We choose a rolling window of 21 days, about 1 month, for volatility. We compute rolling standard deviation, volatility, for each ticker's returns. We create a new figure for the plot. We plot all tickers' rolling volatility lines together. We add a chart title showing the rolling window size. We label the y-axis with volatility in %. We label x-axis with date. We include a legend to tell tickers apart. We space elements tightly. We display the rolling volatility chart. Running the cell now. This chart displays the 21-day rolling volatility of daily returns, capturing how the risk of the asset fluctuates month to month. Notice the changing peaks and troughs in volatility, which indicate periods of higher or lower market uncertainty over time. This visualization helps connect the concept of rolling statistics to their practical use in monitoring dynamic risk levels in financial data. Practice, change the window and see how the volatility line smooths out. Advanced Example 1, Mini Dashboard, Summary KPIs Table. Financial dashboards often display key summary metrics, KPIs, for decision making. Let us compute total returns, median volatility, and the maximum drawdown for each stock. Running the cell now. We summarize major dashboard metrics for each ticker. We start a data frame indexed by each stock ticker's symbol. We calculate the total return for each ticker from first to last date. We take the median 21-day rolling volatility for each stock. We calculate drawdown as the percentage below each ticker's running high price. We take the single lowest, worst, drawdown for each stock and convert to %. We print the KPIs table, rounding to 2 decimals. Running the cell now. Here we see a concise summary table displaying each stock's total return, median volatility, and maximum drawdown, which are key KPIs for financial analysis. Notice the shape of the data frame aligns with the number of tickers as rows and KPIs as columns, summarizing performance and risk metrics over the period. This output directly reflects our goal to create a mini dashboard that quickly informs investment decisions through concise, relevant statistics. Which stock had the deepest drawdown, largest negative number? Advanced Example 2, Dashboard Sector Breakdown, Mock Portfolio. Real dashboards often show how holdings are split by sector. We will use a simulated but realistic portfolio to create a sector allocation chart. Running the cell now. Let us create a realistic portfolio and add sector tags for dashboard breakdowns. We specify 10 well-known tickers across multiple sectors. We start a dictionary mapping each ticker to a sector, Part 1. We continue the sector mapping for the remaining stocks. We finish the sector map so each ticker has a clear sector category. We set the random seed to 42 for reproducibility of share counts. We download 1 year of real closing prices for these stocks. We create an empty list to build position records. We loop through each ticker to fill out portfolio positions. We set the buy price as the first closing price from the year. We set the current price as the final closing price from the year. We build a record for each holding, including sector, buy price, and current price. We assemble all records into a new data frame. We calculate each position's real percentage gain or loss. We display the first few positions to verify. Running the cell now. This table summarizes a mock portfolio showing key details like ticker, shares held, buy and current prices, sector, and percentage gain. Notice the sector column groups stocks into categories like tech and consumer, setting up for a sector allocation visualization. The gain_PCT column highlights individual stock performance, connecting portfolio data to how sectors contribute to overall returns in the dashboard. What is the biggest sector represented? Group by sector and C. We aggregate total shares held by sector. We prepare the figure for our sector breakdown bar chart. We plot the total number of shares per sector as bars. We add a clear chart title. We label the x-axis with sectors. We label the y-axis with share totals. We tidy up the chart layout. We display the sector bar chart. Running the cell now. This bar chart displays the total shares held in each sector of the portfolio, highlighting how the holdings are distributed across different industries. Notice the variation in bar height, which reflects the relative allocation sizes, key insight for understanding sector concentration in the portfolio. This visualization helps translate raw share data into an intuitive sector breakdown, which is essential for building real-world investment dashboards. Try making a pie chart for sector_value equals shares *per_price for each sector. Advanced example 3, export dashboard metrics to file. Saving key dashboard outputs like KPIs allows you to share or archive results. Let us export our KPI table to CSV for report use. Running the cell now. We export the KPI table to a CSV file for later use. We print confirmation that the CSV file was saved. Running the cell now. The output confirms that the KPI dashboard metrics have been successfully saved to a CSV file named dashboard_KPIs.csv. This step ensures that key performance indicators are preserved for sharing or future reference, aligning with the lesson's goal of exporting important dashboard data efficiently. Now opening the exported dashboard KPIs for review. This CSV contains the core financial metrics displayed in the dashboard. Review the CSV to check that your total returns and volatilities match the dashboard. Error handling and debugging. Beginners often struggle with missing data and mismatched date indexes in finance analytics. We show how to detect, handle, and resolve common issues. Running the cell now. Let us check for missing values in our base dashboard data. We check if there are any missing or NA values in the close_wide data frame. We count missing data per ticker column. If any missing values exist, we print which tickers are affected. We display tickers and missing count if present. We fill all missing prices forward, using the last known price. We print confirmation after imputation. Running the cell now. This output confirms that there are no missing values in the close_wide data frame, meaning the forward fill successfully handled any earlier gaps. Noticing the absence of NAs here assures us that the data is now clean and aligned, which is essential before moving to time series analysis in finance. This step prevents errors and inaccuracies that often arise from missing or mismatched data. Add .isna, .sum, after fill to check if all gaps are fixed. Best practices for dashboard code. Use functions to keep repeated code clean and reusable. Always check for missing data before plotting. Use clear chart titles and axis labels so others can understand your work. Set random seed to 42 when randomization is involved so results are reproducible. Keep code and dashboard metrics in sync to prevent reporting errors. Running the cell now. Now let us use a function to handle price plotting for any single ticker. We define a function to plot the dashboard price line for any ticker. We filter for only the selected ticker's rows. We set up the chart size. We plot the date against closing price for that ticker. We label the chart for quick dashboard reference. We label the x-axis as date. We label the y-axis as close price. We show a legend with a ticker name. We adjust the layout to prevent overlap. We display the interactive chart. We use the function to plot GOOGL's price. Running the cell now. This output shows a clean, reusable price chart function focused on a single ticker, demonstrating how to keep dashboard code modular. Notice the clear title, labeled axes, and legend that make the chart easy to interpret, aligning with best practices for clarity and usability. The figure size is set for consistency, ready to be integrated into a larger dashboard without redundancy. Try using a plot_dashboard_price with Tesla or Microsoft. Tiny end-to-end example, dashboard snapshots. You will now create a simple dashboard summary, plot, table, and sector split in 3 lines. This flows from fetching data to dashboards, all in one place. Running the cell now. Here is a 3-in-1 dashboard snapshot, from data to visuals and summary. For the dashboard, we first plot all major tech closing prices together. The line chart displays all tickers' trends over the year. We set axis labels and tidy the layout. We display the KPI metrics as a data frame right in the dashboard. Next, we group and sum up the portfolio's value by sector. We plot these as a pie chart for quick visual allocation. We hide the default Y label for a cleaner pie chart. We show the complete dashboard view, all in 3 code segments. Running the cell now. The plot shows the 1-year price trends for all tech stocks, allowing you to visually compare their performance over time. The table highlights key metrics like total return, volatility, and max drawdown, summarizing each stock's risk and return profile. Finally, the pie chart breaks down the portfolio's sector allocation, giving a quick snapshot of diversification, all together forming a compact, informative dashboard. Which dashboard view is most useful to you? For more Python dashboard projects, check out YouTube tutorials from top finance educators.